Hey everybody, it's Mr. Carr again. Today we're going to be looking at 2.3a. We're looking at equations of parallel lines here. So let's let's first talk about what makes lines parallel. If two non-vertical lines have the same slope, then the lines are parallel to each other. Here's my given line, y equals a negative 3x plus 1. As a reminder, when you do your graphing of these, your b value, which is right here, is their y-intercept. So in this case, like for example, right here, y equals 2x plus 3, we're crossing at the point 0, 0.03. So I'm going to go up to 1 right here for my first point. So that's the point 0, 1. My negative 3, my slope is a negative 3 over 1, because I can put that as a fraction, which means I can go two different directions with that. I can go up to the left, sorry about that, or I can go down and to the right, because up is a positive direction, left is negative, down is negative, right is positive. To have a negative slope overall, we have to have one of each direction. So I go 1, 2, 3 up, and then 1 to the left, 2, 3 up, 1 to the left, 1, 2, 3 down, 1 to the right, 1, 2, 3 down, and 1 to the right. So there's my given line. Here's just one example. And now there's a variety of things we can do with this one, but I'm just going to pick it. So if I make y is equal to a negative 3x plus 4, this will give me a parallel line because the important thing is the slope. It's negative 3 is the same as the negative 3. So I go 1, 2, 3, 4 up. I can go 1, 2, 3, 1, 1, 2, 3, 1. And you can see when I connect those two lines are never going to cross. Okay. Same thing if I go y equals negative 3x minus 5. So minus 5 tells me I'm going to go down 5. So I'm going to go 1, 2, 3, 4, 5 here. And I can do my normal slope, 2, 3, 1, 1, 2, 3, 1, and so on. Okay, and again, drawing those out, they're always going to be the same space apart. They are never going to cross each other, so they are going to be parallel lines. So let's use that in this kind of example. Write the equation line that passes through a point at 2, 4, and parallel to the line 4x plus 1. When I write equations of lines, it's very important to have the slope. And I'm going to look at that here. My slope that's given is 4. Since we're looking for a parallel line, I'm going to call it like this. M, it looks like an 11, but that's M parallel. So this parallel slope is also going to be 4. So we want to first identify the slope from this, which is 4. And then we're going to use that slope in our parallel line, which is the same thing. So if I plug that into my slope-intercept form, that is 4x plus b. But I need to find the b value now. And that's where my x and y come into play. So if I take that 4, plug it in for the y, take the 2 in for x, now I have an equation that I could solve for b. I just need to multiply and subtract it out. So that's 4 is equal to 8 plus b. And then I subtract 8 from both sides, and I get b is equal to a negative 4. Okay, now that I have all that, I'm just going to rewrite it back into its function. So f of x is equal to, well, technically I should use a different one than f of x, so let's use g of x. Okay, g of x is equal to 4x minus 4. And again, this is parallel to this one. Okay, so it's parallel and it just has a different spot that we're looking at on that case. Okay, perpendicular lines. So the key here for perpendicular lines is that these are two non-vertical lines have slopes that are opposite reciprocals. Opposite means that we have one positive slope, one negative slope. And then reciprocals means my fraction a over b is reciprocal for b over a. So we're doing this for our reciprocal idea, okay? So what that means if I try to do this, if I'm given a slope as a over b, my perpendicular slope is a negative b over a in this case. Okay, I'm sorry about that. So in this case, if we do that opposite reciprocal idea, we start with our given line. I'm going to go ahead and graph that. As before, we'll cross at the point 0, negative 2. So we'll start right here. Negative 2/3. So that means I'm going to go up 2, and then I can go left 3, or I can go down 2, and then to the right 3. So I'm gonna go 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. There's my given line. Okay. So when I want to do a perpendicular line, the first thing I got to do is I got to identify my perpendicular slope. So in this case, my slope is -2/3. My perpendicular slope is going to be a positive 3/2. So I took 2/3, I flipped it to the reciprocal. I took the negative and made it a positive. So it does not matter where I put my y-intercepts. So y equals 3/2 x. I can just do the same one. I'll do -2 here. So from this -2, I can go 1, 2, 3 up, 2 to the right. 1, 2, 3 down, 2 to the left. There is a perpendicular line right there. Just for another example, again, it doesn't matter where I do it. So 3/2x plus 3. Okay. So I go 1, 2, 3 up here. Then go 1, 2, 3 up, and then 2 to the right. 1, 2, 3 down, 2 to the left. Okay. So we can see there, they are both going to be perpendicular to the same line, which ties back to a previous lesson. That makes these two lines parallel to each other, which makes sense because they have same slope. All right. So determine if the lines are parallel or perpendicular here. So the biggest thing is we have to identify the slope in each case. So for line B, that one's really straightforward. My slope is 4. For everything else, I need to do a little bit of changing around. So I'll start with this one. I'll subtract x to both sides. 4y is equal to a negative x plus 8. And then I divide everything by 4 here. So I get y is equal to a negative 1/4x plus 2. Over here, let's do the same thing. Let's subtract 12x over. So that's a negative 3y is equal to a negative 12x plus 3. And divide everything by 3. So I get y is equal to a negative 4x plus 1. So my first slope that I found was this one. This slope is a negative 4. This slope is a negative 1/4. None of them are the same, so we have no parallel lines. But I do have an opposite reciprocal here. Line B has 4, which is the same as 4/1. Line C is negative 1/4. They're opposite signs and the reciprocals. So that means that line B is perpendicular to C. Okay. I'm going to let you try these on your own, but I do want to do one problem, which is number 3 here. This is going to work very similar to the problem I just did with the parallel lines. Okay. It looks a lot like this one right here, this example 1. Remember, I found the slope from this, used that same slope to put it here, and then wrote the equation out and then plugged in x, y to find the b. This problem is going to work very similarly, except I'm dealing with perpendicular lines. So I still want to identify my slope. From here, my slope is 1/3. But now before I write my equation out, I want to make sure that I do the perpendicular version, which is a -3 or -3/1. So that is now going to be used in my equation. Y equals -3x plus b. So I'm taking this and plugging it in there. From here, just like the previous problems, I have an x and a y. So I'm going to plug those in. 4 is equal to -3 times a -3 plus b. 4 is equal to 9 plus b. So I subtract 9, so I get -5 is b. So my final answer here is y is equal to a -3x minus 5. Okay, and that's it for today. We're writing equations of parallel and perpendicular lines. Key parts of today. Parallel lines have the same exact slope. Okay, perpendicular lines to form that right angle have to be opposite reciprocal slopes. Everything else is just based off that. All right, that's it for today. Take care, everyone.